Yep, a green, boring Pentium 4 board with an 8GB, PCI, and an ISA slot? 3 ISA slots on a Pentium 4? In the late 90s, ISA slots had already started to become obsolete. By the year 2000, Pentium 3 and early Athlon motherboards would usually come with just one ISA slot, if any. The ISA slot was useful for some legacy cards, like for a DOS-compatible sound card, but by that time, games would support new exciting sound standards, like EAX, that were only available on PCI sound cards. So most folks would just use a PCI sound card for gaming, like the Sound Blaster Live. By 2001 and the wider availability of newer platforms like the Pentium 4 and Athlon XP, practically all chipset manufacturers would just drop the ISA support in favor of PCI. Even though you could still get some earlier Athlon chipsets like the VIA KT133A with ISA support, that was not the case for Pentium 4s. Pentium 4s with ISA slots were never a thing, and I personally had never seen one back in the day. But it turns out that in a strange world of industrial computing, ISA slots were still used for many years to come, so industrial motherboard manufacturers did indeed make Pentium 4 boards with ISA support. I was recently lucky enough to pick up such an industrial Socket 478 motherboard, and it comes with not just one but 3 ISA slots. It's a Portwell PEB-7702G2A, and it's based on the Intel 845E that supports single-channel DDR266 and CPU frontside bus of up to 533 megatransfers per second. This board came with a Celeron, but I think the board should be compatible with one of these really neat 3.06 GHz Pentium 4s with hyperthreading. Oh, and it comes with dual gigabit Ethernet, nice! Okay, so how did they get ISA slots to work with these chipsets? Well, it all comes down to this PCI to ISA bridge chip, in this case the ITE IT8888F. On one side it connects to the PCI bus and the chipset, and on the other side you get a complete ISA bus. On the host side it talks to the host chip using the serialized IRQ, PCI DMA request, and PCI DMA grant signals. And yeah, if you have ever checked out the pinout of an SB-Link connector of a PCI sound card, these are the same signals. Okay, let's power it on. And yeah, we're getting postcodes. And an image, nice. And how cool is that? The BIOS is showing some really nice information at the bottom of the post screen. I've never seen that in a motherboard before. Okay, let's plug in my trusty CT2970. And yeah, it got initialized with Unisound just fine. Now let's try Duke 3D. We are getting music, but digital audio isn't getting detected. What a bummer. I tried several other games off camera, but they all had the same issue. No digital audio. This is usually caused by some DMA issue. Let's check the BIOS settings. I can find some IRQ settings, but I don't see any DMA settings. This is very disappointing. Maybe this is a BIOS issue and the ITE chip wasn't initialized properly? Well, after searching online about this board, I came across this awesome thread at Vogons. User hpxca is claiming that the revision 3.3 of this motherboard has a manufacturing defect, where the DMA request and DMA grant signals coming from the ITE chip are swapped and connected to the wrong pins of the host chip. And not only that, but this thread also shows you how to check for it and how to fix it. This is why the retro computing community is so awesome. What makes this even more amazing is that the host chip is a BGA package, so figuring out where each trace connects to which pad on the chip requires some mad reverse engineering skills. Thank you user hpxca so much for doing all this hard work and sharing it with everyone, much appreciated. Okay, so my board is a revision 3.2, so the chances are that the manufacturing defect is still there. So let's confirm it. I'm checking for continuity between the ITE chip's PCI DMA ground pin and the second pin of the resistor array, which connects directly to the request pad on the host chip. And yeah, I'm getting continuity. Same for the ITE chip's request pin and the last pin of the second resistor array, which connects to the host chip's ground pad. Yep, this confirms it. My board has the same manufacturing defect. Okay, so all we need to do now is to rewire the traces at this convenient location at the back of the board. Let's do it. First I need to cut the traces. These traces are really tough, I need to dig deeper. I think that should be enough. Let's confirm that there is no continuity. Okay, now I won't try this X bodge wire trick shown in the Vogons thread because that requires covering the bottom wire with a solder mask. So what I'm going to do instead is go around the first wire. Okay, this looks good enough. I need to protect this with solder mask or some sort of resin or glue, but for now some Kapton tape will do. Let's check if the sound works. And will you look at that, it does! Oh, that's so awesome! Let me play some Duke to celebrate.
Let's rock. Damn, those alien bastards are gonna pay for shooting up my ride.
Oh, and by the way, I noticed one annoying thing. Once my BIOS settings reset to defaults, I could not boot anymore. Even though my SD card adapter was being detected by the BIOS, it would just refuse to boot. Same with an ID to SATA adapter. But if I reset to failsafe defaults, then it will boot just fine. I checked the differences between the optimized and failsafe defaults, and it turns out that the option that triggers this behavior is the UDMA setting for the IDE controller. Disabling it seems to let the system boot from the SD card. If you have any idea why this might happen, please let me know in the comments. That's all for now. I'm really happy that this board is now fully DOS audio compatible. All the credit for this fix goes to Vogons user hpxca. You are my hero. I would have never considered checking if the wiring on the motherboard was wrong. I hope you enjoyed the video, and as always, thanks for watching and goodbye.